cool group. My name's Sam Julien. I'm a developer at Energy Trust, which is the coolest place ever. I also do some stuff with Treehouse as a mentor. Do a lot of weird hobbies like blacksmithing, and most importantly, I'm your friend. Yay! So, I'm going to be talking about, I didn't even say. I'm going to be talking about functional reactive programming with hardware. And my sister's emailing me. That's awesome. My sister is really great, and she just had a baby too, so it's all good. This is a bit of a challenge for a lightning talk, because there's like a ton of information. Quick poll of the audience. Who here's done anything with Internet of Things, like IoT, hardware, stuff? Good number of you, awesome. What about functional reactive programming like Rxjs, Observables, all that, Redux? Nice, yeah. Cool, so I'm just gonna give you a taste of IoT and a taste of functional reactive programming, and then show you some code of what I'm working on right now, and give you a bunch of resources for where to go from here. The too long didn't watch is that basically open source hardware plus the NPM ecosystem go together like Abby and Alana. Broad City. Yes. So, quick IoT primer. IoT is like the coming second industrial revolution, hopefully without the robber barons and all the social injustice. But basically, there's this idea that anything that can be automated will be automated, labor-wise, which is pretty crazy. And it's basically connected devices, just devices that have internet connectivity and can talk to each other, and can talk to your computer, talk to the internet. And there's a bunch of different varieties. I call these the dumb ones, because they're basically, so we've got, this is the ESP8266. It's a $2 chip on a $12 board and can connect to Wi-Fi. It's pretty cool. And then this is the Arduino Uno. So these are microcontrollers that you flash with firmware, and they do exactly what you tell them and nothing more and nothing less. On the flip side, you've got Raspberry Pi, which is basically like a little computer. It can run Linux. So you've got the Raspberry Pi 3, that's $35 like this. And then you've got the Raspberry Pi Zero, which is an entire computer for $5, which is just crazy. So the first time you start learning hardware as a developer, you're just like, I don't know what's happening here. And you find yourself being really proud of yourself for making LEDs blink. Because you're working on this C language and putting together circuits and how do I debug hardware, and it's just it's crazy. So if you start to get into this, don't get discouraged, because it's pretty gnarly at first. But thankfully, these saintly people have made this firmware called Fermata that is kind of like MIDI. Ben talked about MIDI a little bit last week, but it's like a protocol where the board can connect with input and output, which is really, really useful. So you flash that firmware, and then these wonderful people is it Boku? Yeah, Boku. Yeah, Rick Waldron and company, who are responsible for Grunt, made this thing called Johnny 5, which is a JavaScript API for Fermata. And it's just amazing, because you can use JavaScript in kind of a host-client relationship with these devices. And then what's really cool is you can hook this up into a server with Socket.io and communicate back and forth on a server, all in JavaScript, top to bottom, which is just crazy and awesome. And what that got me thinking was, well, if we can hook this up to Socket.io, that means we can basically connect the entire node ecosystem. So any type of technology, any type of front-end technology or server technology, we can start hooking into these devices and messing around with. And that got me thinking, I'm an Angular developer during the day, and in Angular 2, it's all about functional reactive programming and Rxjs and observables. So that got me thinking about functional reactive programming and IoT. So what is functional reactive programming, or what is FRP? Unfortunately, FRP does not stand for furry rows of puppies. I really, really wish it did, and I threw this GIF in because why not? But functional reactive programming is so new, it's 20 years old. It's actually been around for like 20 plus years. It's been a concept since at least the early 90s. And it's really come back lately due to just the sheer amount and complexity of the data that we're working with now, and this great demand to be asynchronous. I always use the example of Netflix, which is a big proponent of Rxjs, because if you think about all the different data about your Netflix, not just what you're watching, but how you're watching it, how long you're watching it, where your mouse is going on the screen, all of that crazy stuff, and it all has to be in sync across all of your devices. And it turns out that functional reactive programming is just a really good way of handling all that. So you have this convergence of unidirectional one-way data flow that the React world kind of gave to us through things like blocks and Redux and all that jazz. And then you've got recently this return of functional programming. It seems to be in vogue over the last couple of years. So all of this has kind of come together to bring us things like Rxjs. So just really quick, and I'm not even going to spend much time on this, but functional programming, in case you don't know, stresses pure functions with no side effects. It's very declarative as opposed to imperative. Examples would be like the language Haskell and recently Elm. And you see a lot of array functions in JavaScript like map and filter and reduce using these functional approaches. It's just another skill like object-oriented. It's not like the holy grail of programming, but it's really useful for certain things. And there's lots and lots of resources out there on functional programming. Reactive programming, on the other hand, or not on the other hand, it's like another finger on the same hand. Reactive applications are asynchronous and event-driven. And the best example that I've heard is to think of an Excel spreadsheet, which is obviously a dramatic oversimplification. But if you think about your Excel spreadsheet, if you've got a value in a cell and then a bunch of functions that are dependent on that value, as soon as you change that one value, all those other cells update in real time. Like you don't have to go back through each one and tell it that the value changed. And that's kind of the idea of reactive programs. So what kinds of events? Well, there's streams. There's sequences of events over time. And really anything can be a stream, from mouse clicks to data from a server. And that's what got me thinking, like, well, if anything can be a stream, like, what about like data from IoT? So what's great is then you can think of these streams as just arrays of values and then operate on them like any other array. So mouse click coordinates or analog sensor data or whatever. So if we put it all together, we have this thing called functional reactive programming, which is this kind of concept that entire applications can be built around streams. You can create and identify the streams in your application and then combine and subscribe to them, which is kind of abstract, but this could be anything from your API endpoints to your UI interactions, anything like that. You just pick those out and then assemble them all together. And Rxjs is a library that helps you do this. It's the JavaScript version of Microsoft's reactive extensions, which is another thing that came out back in the 90s. And it enables the creation of reactive applications through these objects called observables. So observables are a data type introduced by Rxjs to help us create, subscribe to, and react to streams. They're asynchronous and push-based, and you kind of think of them as the API for the stream, not like the stream itself. This is a really handy table that basically, I mean, most people are somewhat familiar with promises from other JavaScript development. You can kind of think of observables as the asynchronous thing in data handling for multiple return values instead of just one promise. Another key difference is that observables can be canceled, whereas promises can't. Like once you send out that promise, it has to return with something. Whereas the observables can actually be canceled in flight, which is super cool. So, like I said, Rxjs operators are really, really similar to array operators. There's tons and tons of them. But for example, you've got map that works just like it does in an array. There's also this thing called flat map that, because technically when you're mapping a function over an observable, it returns another observable. So then you get this like observableception of observables within observables. So you have this flat map thing that combines them all together into one thing. Likewise, we have this thing called filter that just works just like the array filter. and reduce, which works just like the array operator reduce, and then scan, which works kind of like reduce, except it gives you the intermittent values, which is super useful. And this is ES6 arrow syntax. I apologize, I'm taking a lot of things for granted, and it's not because I'm trying to like talk over anybody, it's just that there's like a limited amount of time. So if you have any questions about any of these things, please come talk to me, ask me questions. I don't want to alienate anybody. So there's a super handy guide called which operator to use that can just, it's like a flow chart of like, I want to do this with my data, and this is how you do it. Which may leave you feeling like this. It's a lot to digest. So, all of that is like the basic groundwork. So I was simultaneously learning all this hardware stuff with all this Rxjs stuff for Angular 2, and it just kind of got me thinking about combining the two. And then I thought it would just be irresponsible if I had like IoTReX, like, and not combine them to like IoTReX. But so basically, you've kind of got this different hardware, like different stack of technology that you're working on. The first thing is the hardware circuit. This cord is tangled. The first thing is like the hardware circuit, like the actual thing that you're wiring up. Then you've got Fermata, which is actually the firmware that's flashed on the chip itself. Then you've got Johnny 5, which is interacting with the board. And then you've got Socket IO, which is taking that input from, or that output from the analog sensor on the board through Johnny 5, and then passing it to whatever server technology. It could be Happy.js or Express or whatever. And then you've got your front-end tech, which just could be anything. For me, it's Rxjs. Oh, I should also take this opportunity to say that the Johnny 5 Socket IO combo was, I got that idea from Rachel White, who made this cool automated cat feeder thing called RoboKitty. It's the best thing ever. She's been talking about it all over the place, so find one of her talks and follow her on Twitter because she's hilarious. But yeah, you could do anything you want with the front end. So let me, without further ado, show you a little code here. So what I've got here is let me show you the actual device setup here. This is Visual Studio Code. I'm on a PC. I'm a C# developer. I apologize. So here's where we're declaring. Can you see this? Yep. Okay, sweet. So this is within a Happy.js stack, and this is decorating Socket IO, and this is just pretty straightforward. Like Johnny 5 takes so much of the work out of dealing with hardware. I mean, you literally just say like board.on and photoresistor and things like that, which makes it really, really easy to work with. Because basically what you're doing is you're setting up a host-client relationship. The board itself actually is not reading JavaScript at all. It's all being translated down into this lower level language. You actually can run embedded JavaScript on some devices like this, but that's a whole different topic for another day. So basically, Socket IO is just emitting the photosensor data that's on this board. I've got 2 photosensors plugged in here, and it's just sending it up the stream. And then on the client side, we've got connecting to Socket IO. I'm using this little library called Marvelous that helps visualize your Rxjs stuff, your observables. But here in line 9 is where you're actually creating an observable from the socket, from the event stream, for the first photosensor. And Rx comes with all these built-in handy operators. So this one is distinct until change. So it's basically just taking that stream in real time and analyzing it and only spitting back out the distinct values, the new values, which is great because you don't have to actually like filter through all the data yourself. And just to make this a little bit clearer, I've got like minimum readings and maximum readings for the first photosensor. So I've got the dot scan thing, and it's basically passing in your minimum, like a map.min, and then doing distinct until changed, and likewise doing the same thing for a maximum. Then, and this is dependent on whether I can get audio from this, but if I can't, it's all right. So I found this library called Timbre.js, that's an audio library for synthesis. And you can basically take these photosensor readings and within the observable map them to frequencies. So I basically made a little like light sensor theremin here. And the same thing happens in the with the second photosensor. So let's see how this goes. Pray that the IoT gods are with us. So fire up the server. And so this is reading the photosensor data. And up at the top line is the first sensor data. The second and third are the minimum and maximum. So if I like put my hand over this, like put it down here, it generates new values. And if I like bring it up here, it generates maximum values. And then there's the second photosensor. I don't know. Oh, there we go. It's not the like prettiest sound in the world, but if I close it up, it's like doing that. I should make it like a prettier sound, but I didn't have time for that. So yeah, so that's it. And like I said, you can do like anything. My original plan for this talk was I'm working on a Redux app to control this board wirelessly, but TypeScript got mad at me and wouldn't let me do it. So, all right, to wrap things up. So obviously this is like a really like silly little prototype, but it's cool because it gets you thinking like, what if the device was better, like if you were using a little wireless device? I mean, this has a breadboard on it, but look how tiny that thing is. It's really small. Or what if your server side was more sophisticated instead of just like a prototype server? Or your front end, like I said, could be all the way up to using Redux and Angular 2 with TypeScript. You can build some pretty cool data visualization platforms with this stuff, like with D3 and all the other buzzwords out there. The other thing I'm excited about with this kind of thing is there's so many applications for IoT merged with open source software, whether it's industry or agriculture or social justice. I mean, what if there were like smart devices being distributed in third world countries? And there's crazy stuff happening. There's also a bunch of crazy stuff happening with IoT and cryptocurrency, things like Bitcoin and Lisk and Ethereum. So there's lots and lots of different ways that these things can be used, which is super exciting. So there's a bunch of different resources for both IoT and Rxjs, and I'm going to tweet out the slides. We have a JavaScript IoT meetup in town, and I'm giving a longer version of this talk on June 23rd. So I'll be able to expand on a lot of this stuff. We also have a really cool wiki on JavaScript and Internet of Things that Liza Gardner started for us. And then this guy, Tom Moxon, who's a really cool engineer in town, he did like synthesizers for Depeche Mode and stuff like that. He built a hardware wiki that you can check out. I've also written a bunch of blog posts on this stuff, and I've got some other resources there. With functional reactive programming and Rxjs, there's lots of different things. I made a couple of blog posts about just kind of compiling a bunch of resources on functional programming and observables. There's also some excellent courses on Egghead. The Redux course by Dan Abramov is like perfect. It's wonderful. So that's a good one. And then Code Cartoons. If you haven't seen Lynn Clark's Code Cartoons, she's a genius, and she makes these little animated drawings explaining Redux and Flux and all the other Facebook buzzwords. And that's all. So thank you so much.